Alright, so this is group 1, and we had problem 8. So the circuit we had to do is right here. We have to solve this by superposition to find I naught. And we have 3 sources. So what we're going to do is we're going to use superposition to find I naught, not V naught. So the idea of superposition is to find the contribution to the current from each source. So what we're going to do is we're going to turn off each source and find the contribution to I naught. So I wrote an equation right here. So I naught is equal to I prime 1 plus I prime 2 plus I naught double prime plus I naught triple prime. So for I naught prime, what we're going to do is we're going to turn off the 4 amp and we're going to turn off the 2 amp. So once you do that, you redraw your circuit and you take out the 4 amp and you take out the 2 amp, leaving you with just this circuit right here. So after that, what you're going to do is you're going to want to find your equivalent resistance of this right here. So Req is equal to the 12 ohm resistor plus the 3 ohm resistor plus the 5 ohm resistor in parallel with the 10 ohm resistor. So 10 times 10 over 10 plus 10 is equal to 100 over 20 is equal to 5. When you redraw the circuit, you just get one mesh, 12 volts, 4 ohms, and 5 ohms. And we call this mesh 1. So if we do KVL at mesh 1, we start here and we go around in the clockwise direction. So opposite 12 volts plus 4 I naught prime plus 5 I naught prime is equal to 0. And then we have 9 I naught prime is equal to 12. I naught prime is equal to 12 over 9, which is equal to 4/3, which is equal to 1.33 amps.
So now we're going to activate the 4 amp current source and deactivate all other independent sources. So this is our equivalent circuit. Once we do that, we have 3 different mesh. So we're going to apply KVL on mesh 1, and then that would be this one here. Our starting point would be here, so it would be 4I1 plus 10 parentheses I1 minus I2, which equals 0. From that we get equation 1. From then on we apply KVL on mesh 2, which would be 10 parentheses I2 minus I1 plus 3 parentheses I2 minus I3 plus 2 I2 plus 5 I2, which equals 0, which would give us equation 2. Then we look at we apply mesh analysis on mesh I3. Because there is only one current, then our I3 would be equivalent to negative 4 amps. When we solve for the 2 equations and for our 2 unknowns, our I1 equals to negative 2/3 amps, our I2 is negative 14 over 15 amps, and then our I3 equals negative 4 amps. Because our I naught is going through mesh 1, I naught double prime equals I1, therefore I naught double prime equals negative 2/3 amps, which equals negative 0.667 amps.
Alright, for the last part of this problem, we're going to find the I naught triple prime. So we're going to activate the 2 amp source and deactivate all the other sources. And after activating the 2 amp source, we're going to apply the KCL at node B1, which is going to be V1 over 4 plus V1 over 10 plus V1 minus V2 over 5 equals to 0. And we're just going to simplify that equation, which is going to give us 11V1 minus 4V2 equals to 0, and that's going to be equation 1. So now we're going to apply KCL at node B2, and that's going to be V2 minus V1 over 5 plus V2 over 5 equals 2. And after simplifying that equation, we're going to get 2V1 minus V1 equals to 10, and that's going to be equation 2. So after we have those equations, we're just going to solve for B1 using either substitution or elimination to find B1, which is going to be 20 over 9 equals to 2.2 volts. And after we have B1, we're going to use Ohm's law to find I naught triple prime. And since I naught triple prime is going from a lower potential to a higher potential, it's going to be 0 minus V1 over 4, which is the resistance, equals to negative V1 over 4 equals to negative 2.2 over 4, which is going to be equal to negative 0.555 amps. And after we have the I naught triple prime, we already had I naught prime and I naught double prime, so we're just going to add all of those to get I naught, which is going to be equal to 0.11112 amps.